Hello everyone, welcome to free gate lectures for EC. Today I am going to talk about how to find voltage gain and output resistance of various MOSFET amplifiers. There are three MOSFET amplifiers. One is common source, second one is common gate, third one is common drain, also we call it as source follower. Normally in gate exam they ask to find gain, voltage gain equal to V out by V in. We represent it as AV and output resistance R out. And the one thing is, for amplifiers, MOSFET need to be in saturation region. Okay, let's start with common source. This is the common source configuration diagram. Here is the V out. So how is we know that MOSFET small signal modeling circuit is like this, right? This is gate, this is gate, this is source, this is drain. This is the small signal model of MOSFET. This is same for both N-type MOSFET and P-type MOSFET. Small signal configuration figure is same for both kind of MOSFETs. Now let's add this resistance, and in small signal model we need to connect this supply to ground. So this RD will be from drain to ground. Here is the drain to ground is RD, and we are taking output resistance across this. So let's first apply KVL to this. At ground terminal we are giving input V in. So V in minus VGS equal to 0. So V in equal to VGS. Apply KCL at this terminal. What we will get by applying KCL at that terminal? V out by RD, and current is leaving this terminal, so this is GM VGS equal to 0. This gives V out equal to minus GM VGS into RD. VGS equal to VI, just replace this here, so this will give V out equal to minus GM VI into RD. So V out by VI is equal to what? Minus GM RD. This is the gain. Let's find R out. For R out, first thing is short circuit the voltage source or open circuit the current source. Second thing, connect VDD to ground. Third step, apply test source at output and find V by I ratio. Okay, let's do that. This is Vn. So to find R out, what I said, connect V into ground, and source is already grounded. This is voltage dependent current source, and we are taking output against across RD, and I said VDD must be grounded. That's why this RD is going from drain to ground, because this VDD is grounded. Now connected test source across this and find V by I ratio. Apply KVL here. It will give 0 minus VGS equal to 0. This gives VGS equal to 0. This VGS equal to 0 means what? 0 means current. This current source is open circuited now. Now all this current will flow through this RD. So V equal to IRD. So V by I equal to RD. This is what we call as output resistance. Okay. The previous case what we discussed, that was without channel length modulation. Now we will find the gain and R out with channel length modulation. Means lambda is not equal to 0. This gives finite RDS. Also we can call it as R0. This refers to drain to source resistance. Let's draw the circuit with channel length modulation. RD, drain resistance, VDD, Vn, and drain to source resistance or not. Let's find out its gain. Small signal model, gate to source, source is grounded, and this is Vn. As usual, voltage dependent current source, RD, and this is connected between drain and source. So drain and source, there is one R0, and across this we are taking output. So as usual, apply voltage KVL here. This gives Vn equal to VGS, and apply KCL at this terminal. That will give V out. These two are in parallel, so that will give RD parallel with R0, and the current is leaving this terminal, so it will be GM VGS equal to 0. So what we get from here, V out equal to minus gm VGS into RD parallel with R0. Now put this VGS equal to VI, so that will give VOT equal to minus gm VI into RD parallel with R0. So I will write this again, equation that gives AV equal to minus gm RD parallel with R0. So one thing what we need to remember here is AV is minus gm RD, or AV is equal to minus gm RD parallel with R0. See, we are getting G minus sign, means inverted version of input. That's why we say common source amplifier gives 180-degree phase shift. This is the important thing, remember this. Only the common source amplifier gives 180-degree phase shift, and no other amplifiers will give this. We will see that in upcoming videos how the gain and R out will be for common gate and common drain. Now we'll find out R out. R out with channel length modulation. RD, VDD, Vin, and this is R0. Let's draw the small signal model. VDS, I said input will be grounded. You have to find R out. This is voltage dependent current source, RD in parallel with R0. To find output resistance, we need to connect one test voltage and find out the current. Apply KVL here. 0 minus VGS equal to 0. This gives VGS equal to 0. This VGS equal to 0 means it will become 0. It is current source, so it will be open circuited. So all this current will flow through these two configurations. So V equal to I in parallel with RD parallel with R0. So V by I equal to RD parallel with R0. This is what we call as output resistance. R out is equal to RD parallel with R0. So in summary, I will write these four equations are important. You try to remember this. Gain AV without channel length modulation equal to minus gm RD with channel length modulation equal to minus gm RD parallel R0. R out without channel length modulation, it is RD. With channel length modulation, it is RD parallel with R0. You try to remember these four equations. This is very important to solve problems. and I will give some two configurations here. You try to remember these configurations. It will be very helpful in solving the problems. Try to remember what I am going to tell here. Whenever a gate is connected to drain like this, means gate and drain are tied together, this gives equivalent resistance of 1 by Gm. 1 minute, 1 minute. And second thing is, try to remember this configuration. These things will help while solving the problems. When the gate is connected to source, this gives an equivalent resistance of R0. And same goes with PMOS also. And gate and source tied together, this gives a resistance of R0. When gate and drain are tied together, this will give a resistance equivalent to 1 by Gm. So these four equations and these four configurations, you try to remember these equations. This will help a lot in solving the problems. These two slides are very important. This one and that equations. Let's solve a few problems now based on whatever we discussed till now. Let's solve one problem. Yeah. Find voltage gain and output resistance R out. The circuit is like this. We are giving V into this is MOSFET 1, this is MOSFET 2. We are taking output at this terminal, and both the transistors don't have channel length modulation, means R0 equal to infinite. R0 equal to infinite. Try to find the gain and R out for this. So I previously said this gate and drain are tied together, means this will give a resistance of 1 by Gm2. Since this is MOSFET number 2, I am giving it as Gm2. Let's draw this one like this now. VDD, this resistance is 1 divided by Gm2. This MOSFET I am drawing as it is, and I am applying input here. I'm taking output at this terminal. So I already gave those equations. So to find gain, what is the equation? Minus Gm into Rd, because we are taking here no channel and modulation condition, so it is minus Gm Rd. Gm is what? Gm is the Gm of this transistor, and Rd is this one. So AV is equal to what? Minus Gm1. Rd is 1 divided by Gm2. So AV is equal to minus Gm1 divided by Gm2. If the transistors are same, means if identical transistors are given, then both GMs will be equal. This gives gain AV equal to -1. Okay, now let's find output resistance for this. Same, how the circuit will look like circuit will be like this. This is V in, this is V out, and this is resistance 1 divided by GM2. This is VDD. So as I said earlier, the ROUT for common source without channel length modulation is RD. So what is RD? RD is 1 by divided by GM2. So RD is equal to 1 divided by GM2. This is the answer for this. Let's try the same problem with channel length modulation. If channel length modulation is given, then what happens? Lambda is not equal to 0. This gives R naught finite value. So how the circuit will look like that time? I will draw here. VDD. This is connected like this. This is like this. We are giving Vn to this. R0 is finite, so R0 will come like this here. This is MOSFET 2, this is MOSFET 1, this is R0 2, this is R0 1. So this is how it looks like. And not to forget, this gate and drain terminal are tied together. So this, what this configuration gives, this configuration will give 1G by GM2 in parallel with R0 2. So how the circuit look like? Circuit will be like this. 1 divided by GM2 is in parallel with R0 2, and this is our amplifier here Vn, and this is R0 1, and we are taking output across this. So I already told the equation for gain with channel length modulation is minus GM RD parallel with R0. So this GM is GM of this transistor, so means it will give what? Minus GM1. This RD is what? Drain resistance, means this whole thing. So it will give 1 divided by GM2 parallel with R0 2. What is this R0? This R0 is this resistance, so that will be in parallel with R0 1. So the gain is minus GM1 into 1 by GM2 parallel with R0 2 parallel with R0 1. This is the gain when the channel modulation is given. Let's find out the ROUT in a similar manner. The circuit will be same. This is Vin, V out, VDD. So what is this? 1 divided by GM2 parallel with R0 2, and here we have R0 1. ROUT for channel length modulation, what I said already, it is RD parallel with R0. That's why I told you to remember those 4 equations. Those are very important to solve problems. We can solve any problem within a few seconds if you know those 4 formulas. Try to remember those. So here what is RD? This RD is this whole thing. What is R0? R0 is this. So replace RD by that value. 1 divided by GM2 parallel R0 2 and parallel R0 1. This, sorry, This value is what output resistance or out. Okay. So what I discussed in this video is this kind of configuration: common source with source grounded and Vout is taken at drain. So here there is no resistance, this source is directly grounded. In my next video I will try to explain the way to find voltage gain and output resistance for common source configuration with source resistance. This we'll try to find out AV and gain for this configuration, and we'll solve few more problems on these, and after that I will go to common gate and source follower configurations as well. So once again I'm telling, try to remember these four equations: AV equal to minus GM RD, AV equal to minus GM RD parallel with R naught, R out is equal to RD, R out equal to RD parallel with R naught. This is no channel length modulation. This is with